our next presentation, paper number 185. তো আপনি আপনার নিজের ইন্ট্রোডাকশনটা দিয়ে নিলাম আমরা সবাই আপনি দেখি তো কোনটা ভিডিওটা হ্যাঁ গ্রেট ফুল স্ক্রিন করে দেবেন না এটা তো লাস্ট স্লাইড ফার্স্ট স্লাইড থ্যাংক ইউ Thank you, sir. Very good afternoon. Myself, Dr. Kutubuddin, working as a professor of physics at Government University, and here is another name. This is my collaborator, Professor Dr. Biran Shah. He is also my PhD supervisor. And today my topic is adsorption cooling. So we said this is an alternative technology towards low carbon society. So today mainly I focus on the adsorption cooling system and why it is important. Actually, I will try to make the presentation very easy and understandable to all. Let's see at first. Let's see the cooling system. So this is the very familiar cooling system we usually use in our house. So this is like refrigeration system, and this is air conditioning system. The working principle for both the system is actually the same. Here the heat transfer fluid is refrigerant. So it is two-phase flow. The refrigerant in the it evaporates, and when it evaporates, it takes some heat. So when it takes the heat from any confined place, the temperature of this space actually reduces. So the refrigerant in the evaporator entered as a liquid, and when it exceeds the evaporator, it becomes a gas. So this gas goes to the compressor, it compresses. When it is compressed, the temperature and pressure increase and goes to the condenser, it condenses, and it becomes a liquid. So this is the flow of refrigerant, and the working principle for the AC is the same, but here in our room nowadays we use the split type air conditioning system. So the evaporator is an indoor unit which is inside the room, and the condenser actually the outdoor unit which is placed at the outside. So nowadays you can see the demand of air conditioning system is increasing, and if you see the building, you will only see the outdoor unit. So the natural beauty of this building is reduced. So we cannot see the architectural view of the building. We can see only the outdoor unit of the air conditioning system. We all know why it is happening, and this is actually happening due to the global warming. We like the comfortable working place. So if you have the economic ability, so definitely we will buy the air conditioning system. So the history of the air conditioning system is very long. At first, the research on this air conditioning system started in 1758, but the commercial air conditioning system actually built in 1933. What is the problem of this air conditioning system? Actually, in 1930, the CFC gas was started to use in the air conditioning system. But before that, the ammonia was used. Ammonia is toxic, but it is not very. It has not very environmental issues. But CFC is very high performance gas. But you know, the CFC has a chlorine component, and when it is released to the environment, it has very vast ozone depletion potential. So it can deplete the ozone molecule. After like the CFC gas dominated almost 50 years. In 1970, the environmental scientists actually demanded to ban the CFC and like chlorofluorocarbon, hydrochlorofluorocarbon, and halon gases. And that time, in 1970, that time the production of this gas was around 100 million tons. In 1974, the Roland and Molina explained that how CFC depleted the ozone layer. And in 1987, the Montreal Protocol was signed to stop the production and use of the CFC gases. And these are the three scientists who later got Nobel Prize for their discovery and their work in atmospheric chemistry, particularly concerning the formation and decomposition of ozone molecule. So nowadays, actually, there is no production of CFC gases. Production and utilization is completely banned due to sign the Montreal Protocol. But this gas has some other problem. So this gas nowadays has a big global warming potential. Now this gas has no ozone depletion potential. These are the widely used gas in air conditioning system. So these are the commercial names. So only R22 is now using nowadays, but it's very limited scale. It has a little bit ODP, but the other gas has no ozone depletion potential. So this gas is not harmful to the ozone layer. But if this gases have a very big global warming potential. This global warming potential means like R22 is 1810. So that means this R22, this gas is 1800 times higher heat trapping capacity than carbon dioxide. So this is compared to the carbon dioxide. So like this one is 1400 times higher heat capacity than the carbon dioxide. So all this white used gas have a very big global warming potential. So another protocol is signed to stop the global warming gases. So this is very known is Kyoto Protocol. This one is signed in 1997, and this is signed in Kyoto, Japan, where the greenhouse the protocol was signed to stop the production and utilization of greenhouse gases. So it has some guideline how to stop the production and utilization. So we cannot stop in within a very short time, but it has a very long plan. So how can reduce the uses of this kind of gas? So these are some actually the target area for this Montreal Protocol and Kyoto Protocol. Montreal Protocol actually initially it was worked for the CFC gas, but now this two protocol is working for the reduction of greenhouse gas. So this one is the target set by the Paris Agreement, which is actually for COP21. So though we have a lot of problem with this AC air conditioning system, but still the uses of this system is increasing. So this data I found in the Japan Air Conditioning Society website. They say in 2016, world air conditioning demand was 102 million units, which is 3% higher than the previous year. So I don't have the very recent data. This is like 2016, but you can see that how the demand of air conditioning system is increasing day by day. So what is the problem of this air conditioning system nowadays? Even we don't have any CFC here, but we know the air conditioning system actually create problem in two ways. One is like energy consumption. In the air conditioning system or refrigeration system, it uses a huge amount of electricity. For global context, it consumes more than 15% of the global energy. And for the household building, it consumes around 50% of the total energy consumed in our house. And so this is one problem. So the energy consumption is actually indirectly related to the carbon dioxide emission. So for example, I found one data in Japan that for 1 kilowatt, the production of 1 kilowatt electricity, they release half kilogram carbon dioxide. So this is Japan data. I think if we see the Bangladeshi power plant, definitely to produce 1 kilowatt electricity, I think the carbon dioxide emission will be around 1 kilogram or more. And it has another problem is the gas. So the gas has the global warming potential. So the problem associated with this system is two. One is the energy consumption, the uses of global warming gases. So I calculated the total equivalent warming effect for a single air conditioning system. For domestic, actually, this one is for domestic air conditioning system like 1 ton 5 system. So I found the equivalent warming effect. If I consider 10-year lifetime for a air conditioning system, then I found that one single air conditioner unit actually emits around 10 to 12 ton equivalent carbon dioxide for its 10 years lifetime. So one single unit air conditioner actually emits around 10 ton amount of equivalent carbon dioxide. So this is very huge. So what is the alternative actually? If we want to reduce this amount of carbon dioxide, so if we have any alternative system. So we found one system which can be used as an alternative of the conventional air conditioning system. So this is the conventional air conditioning system, as I said before. They have evaporator, compressor, condenser, and expansion valve. So we have another system. So this system can give you cooling, but the system is driven by heat, not by the electricity. So this is one thing. Another thing is here we use a gas which has a very high global warming potential. But for this system, we can use simply water as a refrigerant, like not like other gas like R22, R14. There are so many commercial gas for this system, but this system we can use only water as a coolant, as a refrigerant. So it has two advantages, like its energy consumption is very low because it is driven by heat, because the compressor for the air conditioning system consumes around 90% of this electricity the system uses. Only compressor uses 90% of the electricity used in this system. So if we can replace this compressor, then we can reduce 90% consumption of electricity. So in our system, we replace this mechanical compressor by a thermal compressor. So how the compressor works? So for the adsorption cooling system, we use some adsorbing material. So we have material in nature, like this porous material. This material can absorb gas. So in the evaporator, when the refrigerant evaporates, it absorbs in the absorbent. Okay, sir. So it absorbs in the absorbent. So the flow is continuing like this. So when the absorption is finished, like the material is circulated, then we dissolve the material using heat. Just if we warm the bed like 60 to 70 degrees Celsius, then this material dissolve all the gas it previously absorbed. So here absorption is going in this way, but now this valve is closed, this valve is open, and we now just use some water inside the bed, so the material is warm and it releases the gas, and it goes to the condenser and it's condensed and comes to the evaporator. So the cycle is continuing, thus using the absorption and desorption phenomena. So how we do the research in this area? Actually, at first, when we find any material, porous material, we test it in an experiment that how much it can absorb the gas. So like for this experiment, we use the material here, and here is the ethanol. So when ethanol evaporates, it absorbs gas. So we can directly measure the weight of the sample with time. So this is an isotherm data, like at 30 degrees Celsius, how much this material can absorb ethanol vapor or like this. So we have many data like not only ethanol, water, carbon dioxide, or any other gas, you can look at this cylinder and we can check the adsorption amount. So then we calculate, we use some thermodynamics and we have some mathematical equation to gauge the performance of the material. So these are some very special analysis. And finally, for getting continuous cooling, we can use 2-bed or 3-bed or 4-bed. We have different types of simulation data using 2-bed, 3-bed, multi-bed. So if you use multi-bed, then one bed will absorb, then the other bed will dissolve. So then, and after like 10 minutes or 20 minutes, we can change. We can supply the hot water here and cold water here. So this bed will start to absorb and this one will dissolve. So we can get continuous cooling from this evaporator. So now to see the actual performance, actually the previous one is actually the, this one is the simulated data. So here we can see the performance like COP is around 0.5. And to get the actual performance, actually we got a fund from the government, like Bangladesh Climate Change Fund, to establish a pilot plan. Now we are working to establish this kind of plant. So we will first collect the solar heat and we'll store the hot water here, and then we will run our adsorption cooling system and we'll cool the room or classroom. And we want to see how much performance we can get from this system. So these are the impacts. So we think we have a lot of impact if you can establish this system and we can implement the project. So thank you. Okay.
Just কোনো কমার্শিয়াল ভায়াবিলিটি, যেহেতু আপনারা অলরেডি পাইলট প্ল্যান করছেন, প্রোটোটাইপ তৈরি করছেন, কমার্শিয়াল ভায়াবিলিটি কি কোনো কাজ হয়েছে? আমরা বহু আগে দেখেছিলাম যেটা এখন কমার্শিয়ালি ভায়াবল কাজ হচ্ছে, অ্যাকোয়াস্টিক কম্প্রেশন। অ্যাকোয়াস্টিক কম্প্রেশন ডিফারেন্ট টাইপের, ইটস অলসো মেকানিক্যাল বাট নট ইউজ সিএফসি। এই ধরনের কাজের কোন কমার্শিয়াল ভায়াবিলিটি
অ্যাকচুয়ালি স্যার কমার্শিয়াল কাজ হচ্ছে, ইভেন জাপানে ওরা হচ্ছে ফিশিং বোট যেগুলো, ওরা ওইখানে অ্যাডসর্পশন কুলিং ইউজ করতো ফ্রিজিং করার জন্য। আর ইন্ডিয়ান একটা কোম্পানি ব্রায়ার, ওরা কমার্শিয়ালি ছোট ছোট ইউনিট, আগে ওরা ডিহিউমিডিফায়ার ইউজ করতো, এখন ওরা দেখলাম যে একটু কমার্শিয়ালি প্রোডাকশনের দিকে যাচ্ছে এখানে সিস্টেম। ইভেন আমাদের এই প্রজেক্টে ওরা আসলে কনসালটেন্সি করছে, ওদের সাথে জাপানে আমার পরিচয়। তো ওরা আমাদের ওই সিস্টেম যেটা অ্যাডসর্পশন চিলার যে পার্টটা, ওরা আমাদেরকে তৈরি করে দেবে। ওরা কমার্শিয়ালি ছোট স্কেলে করে, আমরা একটু লার্জ স্কেলে চেয়েছি যে একটা বড় স্পেসকে আমরা, কারণ আমাদের টার্গেট হচ্ছে এটা গার্মেন্ট ইন্ডাস্ট্রিতে অ্যাপ্লাই করার জন্য, কারণ আমাদের প্রচুর ওয়েস্ট হিট থাকে। আমাদের যেহেতু হিটটাই দরকার, আর যেহেতু সোলার যদি ইউজ করি আমি দিনের বেলায় শুধু হট ওয়াটারটা পাচ্ছি, কিন্তু গার্মেন্টসে ওদের ফ্যাক্টরি যতক্ষণ চলে ওদের বয়লার রানিং থাকে, তো বয়লার থেকে আমি হিট পাচ্ছি না। আমাদের
ওয়েস্ট ওয়াটারও অনেক
আমাদের এটা লো গ্রেড হিটই হচ্ছে, কিন্তু ওদের অনেক হাই গ্রেড হিটও থাকে।
বয়লারের তো এনে তারপর
ডিসপোজ করে। তো আমরা আসলে যদি ওখান থেকে ওয়াটারটা নিয়ে রাখতে পারি, তাহলে সিস্টেমটা আমাদের যেহেতু ন্যাচারাল সিস্টেম, মানে অ্যাবজর্পশনটা আমরা হচ্ছে প্রেশার দিতে পারবো, এটা ন্যাচারালি অ্যাবজর্ব হবে। তো সিস্টেমটা একটু স্লো, তো এটা ওরা হয়তো আধা ঘন্টা আগে ওরা সিস্টেমটা চালিয়ে রাখতে পারে।
আরেকটা পার্ট হবে আমাদের যে বিল্ডিং এর স্পেস।
এটা জাপানে আমরা একটা ফান্ড পেয়েছিলাম গাড়িতে ইউজ করার জন্য, গাড়ির জন্য খুব একটা হচ্ছিল না, ওয়েটটা বেশি হয়ে যাচ্ছিল, স্পেসটা বেশি হয়ে যাচ্ছিল। তো আমরা আসলে ইনিশিয়ালি ইন্ডাস্ট্রি টার্গেট করে আগাচ্ছি, যদি প্রজেক্টটা সাকসেসফুল হয় তাহলে হয়তো আমরা এটা গভর্নমেন্টকে বলতে পারি যে ওরা কিন্তু প্রেশার দিয়েও দরকার হলে বিভিন্ন জায়গায়, যেহেতু এটা এনার্জি সেভিং টেকনোলজি। আমি আসলে কিছু স্লাইড বাদ দিয়েছি আসলে,
কারণ আমরা যেমন একটা 2 টনের এসি দিয়ে রুমকে ঠান্ডা করতে পারি, কিন্তু গাড়িতে অনেক কম স্পেসের জন্যই 2 টনের এসি লেগেছে।
এসি লেগেছে।
কারণ গাড়ির সব দিক থেকে
অনেক হিট।
সব দিক থেকে
এটা আসলে এবং
থ্যাংক ইউ।
থ্যাংক ইউ স্যার। আসলে আমি আরেকটু লাকি যে আসলে আমি অনেকদিন আমার এই দিনটার জন্য ওয়েট করছিলাম যে আমি হচ্ছে অ্যাকচুয়ালি আমার চাচা, আমি অনেক সময় বলেছি যে রিসার্চ আমি করি, তার সামনে কোনোদিন প্রেজেন্ট করার সৌভাগ্য হয়নি।